Hello everyone, welcome to the fourth week of IOQM preparation. We are finally entering geometry. Hello everyone, welcome back to this channel. Welcome back to the IOQM series which we are doing now. Today we are going to do congruency. Basically we are comparing two of the triangles. We are comparing two triangles, and one tool, one very interesting and very important tool is congruency. Now, I used to often think, right, when I was your age probably, I used to think, why do we even study triangles only? I mean, we do study quadrilaterals eventually, but why only triangles? Because every other polygon, every other shape can be divided. We study triangles and then we go to circles, and in between we will do a little bit of quadrilaterals. But quadrilaterals we only study the types of quadrilaterals, a bit of properties, but that's also basically parallel line stuff. Yeah, the parallelogram properties are basically the corresponding angle, alternative interior angle, those kind of things. Yeah, so why do we study triangles more deeper than we do for any other polygon? Because every other polygon can be divided into triangles. If I want to study this, I will, if I study somewhat of this is three triangles. So every polygon can be divided into triangles, and that's why if we have a good understanding about how triangles behave, how to compare two triangles, and upon comparison, what is the thing which we get? So I'm planning today's video in a very peculiar way. It will be probably a very short video, relatively shorter video compared to the videos I've been uploading, but this will be something different. So when do we say, this is the symbol of congruency, by the way, congruency. We say ABC, triangle ABC is congruent to triangle DEF. When does this happen? When the moment I use the term congruency, I mean overlapping, as I said in the previous video also, right? We overlap two things. If two things are exactly overlappable, then we have two congruent figures. Now these two figures are congruent, meaning ABC and DEF, if we put them on top of each other, they will be exactly the same. They will be exactly the same when we put them on top of each other like that. Yeah, you understand? So that should mean that these should be exactly the same. These are the three sides and these are the three angles. The corresponding sides and angles, that means corresponding sides and angles, they should be the same. When are they same? When the two triangles are overlapping. Do all six need to be the same? If you have watched my previous video, you should have now got the idea that no sir, not required. We just need at most three of them to be the same. I mean, we need at least three of them to be the same, right? And that too in a particular order. We cannot say any three information if we have a triangle. For example, if we have the angles to be the same, we won't have congruency. So it is exactly related to congruency is directly related to the uniqueness of construction. Right? It is directly related to the uniqueness of construction. For example, SSS congruency is there. These are all, congruency is not a big thing. It's not a subject to study in itself. It is a tool. I want you to remember that. Congruency is merely a tool and nothing more than that, right? But it is very important to remember the tool. It is very important to remember how to use a hammer and a sickle. Only then will you be able to, build things, cut cops or something. Anyways, SSS meaning only AB is equal to DE, BC is equal to EF, CA is equal to FE, FD. If these three are holding, that means this implies triangle ABC is congruent to triangle DE. I'm just telling you the formal statements so that you understand. So if only three of them following, yeah, in the previous one, only these three give SSS. These three. But if I take, two of them, maybe I'll use another color for that. Is that even visible? Yeah. So if I use ABC and BCD, AB equal to DE, BC is equal to EF, and then I have the common angle B equal, then the blue one, the red one gives me SAS, right? So let me write that down. SAS tells me that if AB is equal to BC and AB is equal to DE, I'm so sorry, BC is equal to EF and angle B is equal to angle E, that again implies triangle ABC is congruent to triangle DEF. Because, do you see the uniqueness of construction, the relation with the uniqueness of construction and congruency? Because the moment you have one of the triangles' property, there is only a unique triangle which you can construct with the same information, right? If you have that three sides are the same, then three corresponding sides are the same, then there can be a unique triangle with that configuration. That's what we did in the last class. So the last class, if you have not watched it, this video will be a little bit, it will feel like I'm hand waving, but I'm not. I have done it in a very deeper way in the last class. Please watch the previous video, right? And then for the third one, we have, now let me use another color. We have, if I have only one side equal and the two corresponding angles are equal, angle A is equal to angle D, angle C is equal to angle F. So these three together will form ASA, right? So third one is ASA. If ABC CA is equal to FD and angle C is equal to angle F, angle A is equal to angle D. Again, that also gives me triangle ABC is congruent to triangle DE. Right? We also have an RHS thing, which is, that is again specific for right angle. So if angle A is equal to angle D is equal to 90 degrees and AB is equal to DE and BC is equal to EF, right? This happens to be hypotenuse, this happens to be a side. This is RHS, right? That again implies triangle ABC is congruent to triangle D, where both are right angle triangles. This is the congruency criteria. So I again request you to watch my previous video, because I had done that in a very detailed manner. Now, I'll do one example and that will be the end of this video. So one example is, I'll take a isosceles triangle. Yeah, I'll take an isosceles triangle ABC. Triangle ABC is an isosceles triangle. Prove that the following are equivalent. A. So I'll draw a line AD. AD is perpendicular bisector. Or maybe simply AB is a perpendicular, right? You can simply take it as a perpendicular. What are we doing? There is. AB is an altitude, or AD is angle bisector, perpendicular or altitude, right? C, it could be perpendicular, it could be that, or it could be median. AD is a median. I hope you know what this is. Altitude is when in a triangle, when you have this to be perpendicular, right? This is to be 90 degrees. Angle bisector is when in a triangle this line is bisecting the angle in equal parts, right? Median is the line which joins the midpoint of the opposite. Midpoint of the opposite. I believe you all must know that. Now, how do we, solve these kind of questions? This is a proof-based question. I am asking you to prove all these are equivalent. So generally, the method to solve these kind of questions is, let me just, before we begin, showing all these are equivalent. The method is that we start from one of the statements. Let's say we start from A. We prove that this is, if we start with this, we assume this. If we assume A, we get B is true. If we assume B, then we get C is true. If we assume C, we get A is true. So we go like this. So this becomes a complete circle. So all these three become equivalent, right? When I say equivalent, that means if one holds true, the other is true. If the other holds true, then this is also true, right? So we will do that. So let's start with AD is a perpendicular. So first we start with A implies B. So we take a triangle. A is that perpendicular. B says it is angle bisector. Right? Now we know that it is perpendicular. Given AD is perpendicular to BC. Okay. Then what do I do? If AD is already perpendicular to BC, I need to show it is angle bisector. That's what it was, right? The second was angle bisector. To show angle BAD is equal to angle CAD. Okay, so we need to show that if it is a perpendicular, then these two angles are same. In all three cases, I am revealing it to you that in all four cases, we need to have four implications here, right? 1, 2, 3. Okay, only 3. Fine. So in all three implications, we need to use some tool to show that triangle ABD is equivalent to triangle ADC. Is that correct? Is that correct? That's wrong, right? That's wrong because the order is wrong. Very good. If you had pointed it out, very good. This is what we need to show at the end in each case. So how do I show that? So come in triangle ABD and ACD. Note that, so take this class also as a master class to how to write geometric proof, right? Note that AD is common, angle D, angle ADB equal to angle ADC is equal to 90 degrees. And we know that since isosceles triangle AB is equal to AC, isosceles. And this is because given. This is, of course, obvious. So do you see we have RHS. So RHS congruency implies triangle ABD is congruent to triangle ACD. That implies angle BAD must be equal to angle CAD. This angle must be equal to that angle because these two are congruent, meaning they should be overlapping, and in that particular order we want this angle to be equal to this angle, right? So BAD is equal to CAD. That should be the order. Is that understood? Okay, now let's move to the next one. Suppose now we want to prove B implies C. So I again take the triangle. B says it is angle bisector. C says it is what was it? Median. Median means simply we need to show BD is equal to DC. This is what we want to show, right? Angle bisector means we are given BAD is equal to DAC. So again, since this is given, this is to show. So with the given thing in triangle ABD and triangle ADC, we again have AD common every time, AD equal to DC. Yeah. we have we are given angle BAD is equal to angle CAD, and we also have something else. We have AB is equal to AC. So is that not SAS? That's SAS. So with SAS congruency, we know by what do we know? That these two triangles are congruent, and that should imply BD is equal to DC. And this implies that AD is a median. Is that understood? We can also go from this to this, median to angle bisector. Suppose we want to show C implies B. Suppose we have median and we want to show angle bisector. How do we do that? Which congruency should we use? So think about it. So here we have median, so BD is equal to DC, and BD is equal to DC. AD is common. Did I write AD is? No. AD is not DC. AD is common. AD is common, and then what else do we have? Oh, we of course have AB is equal to AC. So this is SSS. Again congruent. ABD is congruent to triangle ACD. So that should imply again angle BAD is equal to angle CAD. So we are left and right using congruency. Yeah, let's do the last one. We want to show C implies A. C is median. A is what is A? A was what? I think perpendicular, right? A is perpendicular or altitude. So again we draw the diagram just for reference. A, B, C. We are given that AD divides BD is equal to DC. Median, right? To prove AD is perpendicular to BC. How do we do that? So again, in triangle ABD and ACD, see that we already have AB is equal to AC. We have AD divides this, so BD is equal to DC, and again the same thing which we did before, right? AD is common. So this implies by SSS implies by SSS congruency criteria, ABD is equal to triangle ACD, and that will only give us, that angle BDA is equal to angle CDA, right? That means this angle is equal to this angle, but from that implies that angle BDA plus also angle BDA plus angle CDA is 180 degrees because one side of the line BC, because BC is a line. So that should imply that each angle BDA and angle CDA should be 90 degrees because they are adding up to 180 degrees. And that implies AD is perpendicular to BC. So this is a very basic thing. This is actually very basic, but I just wanted to, show this to you. This was a childlike curiosity discovery for me, right? I hope this helps. Meet you soon, right? Good day. Good day. Yeah, that's the end of the video. Come on. Have a good day. Bye.